Previously, we looked at using the AWS Key Management Service encryption keys in applications that are running in the cloud and options to ensure that objects stored in S3 storage are encrypted at rest using the Key Management Service. Let's look at a few best practices for ensuring that the encryption keys themselves are managed securely using the AWS Key Management Service. As we touched on earlier, AWS Key Management Service provides various options for creating and managing master encryption keys. It's important to understand the difference between these options.
The first is using AWS Managed Master Encryption Keys. This is the default and easiest type of KMS key to use. It requires very little management on the part of the customer. This key is provisioned automatically by KMS when a service such as S3 or EC2 needs to use KMS to encrypt underlying data. A separate master key would be created for each service that starts using KMS. For example, if you created a DynamoDB table, by default it would be encrypted with the AWS Managed KMS key, and the user would not need to explicitly create a key. Once the table was created, you would see a new key also created in KMS. With this method, key rotation is also handled behind the scenes by AWS, and keys are rotated every 3 years. Also, AWS managed keys do not incur usage costs. Permissions to AWS managed keys are also handled behind the scenes. Any principal or user who has access to a particular service would inherently have access to any encrypted data that the service had encrypted using the AWS managed keys. Using the example of DynamoDB table that has encryption using AWS managed keys, all users or roles in the account that have read access to the DynamoDB table would be able to read data from the table. The main drawback here is that we cannot apply the principle of least privilege access to the keys. It would not be possible to segment and isolate permissions to certain keys and encrypted data. In addition to this limitation, AWS managed keys are not available for applications to use for a client-side encryption, since they are only available for use by AWS services. As you can see, this approach is acceptable if the sole requirement is to ensure that data is encrypted at rest in AWS data centers. This approach is also not recommended for accounts where sensitive data is present, since in the event of the AWS account or role compromised for some reason, encrypted data may not be protected. The second avenue for implementing the key management service is by creating customer-managed customer master keys in the AWS Key Management Service. In this situation, cloud customers will explicitly provision and manage the key lifecycle. The customer would also be responsible for managing permissions on the keys related to which entities can manage keys and which principals can use the keys for cryptographic operations. Behind the scenes, AWS will create the key material and rotate keys on a yearly basis. This is transparent to the user. The user does have the option to choose to manually rotate the keys. The main benefit to using customer-managed keys is that permissions to manage and use the keys can be explicitly defined and controlled. This allows separation of duties, segmentation of key usage, and least privilege access. Again, using DynamoDB tables as an example, we can have much more flexibility to restrict access to data by restricting access to encryption keys. For example, we can have 2 separate master keys for 2 different sets of tables designated by data classification, such as sensitive versus non-sensitive. We can also assign certain IAM roles to be able to use the keys. Perhaps we want to segment 2 different applications to their respective tables. In that case, we would only allow the role for application 1 to be able to use key 1, and the role for application 2 to be able to use key 2. Application 2 would never be able to decrypt data that was encrypted by key number 1. We would want to also restrict management of the keys and key permissions to a separate IAM role. With that protection in place, Application roles will not be able to change permissions on the keys in order to use the keys to decrypt the other application's data, for example. This approach is a great balance between manageability and security and will generally provide the capabilities mandated by most compliance and security standards. When new customer master keys are provisioned in KMS, by default, KMS creates and maintains the key material for you. However, KMS also provides the customer the option of importing their own key material, which may be maintained in a key store external to KMS. With this option, the customer has full control over the key's lifecycle, including expiration, deletion, and rotation. A potential use case for importing key material may be to maintain backup copies of the key material external to AWS to fulfill disaster recovery requirements. Customers may also find this option useful if they have a desire to use one key management system for cloud and on-premise infrastructure.